Hello and welcome to another presentation of Indies Education. Today's presentation is again another soldering practice video. So what I will do is I will just try to justify how far I can go without proper soldering microscope and industrial soldering flux. So basically this is my DIY setup. So I have my kit of ST-862D, that's an Atten. Maybe you have seen my previous unboxing video. I have just started and I am not a pro, but I am trying to learn things, and welcome on board. Thank you for being part of my journey. And I've got my Hako FX951, pretty decent soldering station. Now let's get started. So basically these are the nozzles for the Hako. I will get the setup in a minute. I have done some modification of the soldering heat gun. So what I will do is I will put it in my tripod. I mean the robotic arm, and this will be hopefully this will be quite handy for soldering. So I don't have to hold it for longer period of time. I will have a spare hand just to help with my desoldering. So what I will do is I will desolder these parts. As you can see, this control board from optical DVD drive. So I will desolder some of the part from that control board, and I will try to solder it back. It's just to justify the limitation, because when you start something, you can buy lots of expensive equipments, but what are the justification? You see fancy videos, but that's not your experience. So basically I will try to see that how far I can go with my DIY soldering setup. I have this soldering flux, which is basically isopropanol alcohol. This isopropanol alcohol, and it is 50% isopropanol alcohol and 50% of the amber soldering amber, which is, I think, is resin, soldering resin. So 50% of the isopropanol alcohol and 50% of the soldering resin, which are kind of amber, come from natural tree sap. So what I will do is, as you can see, I am holding this with this arm. So now let's get started and see how far it can go. But before that, what I will do is I will definitely I will disconnect this cable. So let me disconnect this cable, but this one is not possible to disconnect. This one is soldered, hard soldered with the board. There is no socket mechanism, and I'm pretty sure that I can't desolder this part, because this part is it is a double layer board. So basically there is only one way it can be desoldered from this part, but by this way it can get melt. To compensate that, see if it is possible, I will put some Kapton tape, so which will be basically will work as a heat insulator. So this is the Kapton tape. I will put some of the Kapton tape on top of that socket, plastic socket, just to prevent it from melting. Now let's get started again. So I will cover it with the Kapton tape just on this part, so that heat is accessible to the pins. Okay, so I'll keep it on this way, and let's cut it. So as I put it in this way, first I will desolder this part, then I will go for the next part. Let's get started. So at the moment I have to get my solder on. So basically, as you can see, this is the button for turning it on. So I press the button. As you know, as you can hear the sound, that as soon as I press the button it is coming off. But let's turn it off again. So I think the magic setting is I think the magic setting is 50% air at 400 degrees Celsius. So I will try to use one of the nozzle from there, but first of all I need to make the board stable. So for this, let's see, it's a bit heavy for the whole setting. I will try to, yes, let's see if it can hold the board, but it will be difficult. I'm sure it will be difficult for this to hold the board. No. So what I will do is, again, okay, so my robotic arm is handy. I will lower it, make sure I don't burn anything, and I don't burn any part of the table, and then I will use a bigger nozzle to take off the whole thing same time. The problem with the nozzle is that sometimes if you use one nozzle, then they get pretty tight. You can take it off once it is warmed. That's why I'm not putting it properly. I don't think so there is a big danger with that. Now let's see how our things work. So as you can see, my setting is working pretty right. Only the thing is, I will get a cotton bud and put some flux on top of it. Flux work as a heat conductor, so basically it equally distribute the hot air gun heat. So I'll put my DIY flux and let's see what is the result. So I'll put it quite a bit. So basically I soak it. Now let's get started and see how far we can go. So I will turn it on, get it under the microscope. So it is 400 degrees Celsius and I can see there is some melting happening. I'll use my tweezer to take this off. No, I can see some smoke. So basically let me investigate what is happening. Okay, so this part is, this cable is not possible to desolder because this is only one way. You can desolder it, but you can't solder it back because it has got pretty low melting point, as you can see with this small temperature. I think it was just picking up going to 400 degrees Celsius, but at the moment it is melted. But I think it is coming off and it is pretty, it's a bit delicate. So let me take it off from other side. So the other side, these flat ribbon cables, they are really embedded system, and they are for one-time use. They cannot be recycled. So basically you can take the hook off, then you have to put the whole thing. Okay, so this socket itself is look like the Raspberry Pi camera socket. So it's a locking mechanism. So I took it off the cable. Okay, now I got my board, only the board. So I dislodged the whole board. Now I put the board on my station, and I think this time it will be much more easier. So what should I try? I should take the big risk, try to desolder this part. So this is the thing, if you don't do, you never know. So I'm just taking the risk and try to learn something from it. I'll put some more Kapton tape on top of it. Again, this job is just to protect it, just to shield it from the heat of the soldering heat gun. Okay, now let's see how this plays. Now I'll get my station back again. I will put it here. We'll try to do some angle. It's not double layered, so there are no way I can gravity feed the whole thing. I mean dislodging the whole thing with gravity. So let me power it on. As soon as if I see some smoke, I will turn it off. The safety feature of the Atten ST-862D is pretty strong. It is really easy to turn off and turn on at the same time. Okay, so the heat is picking up. It takes almost like 4 seconds to get 410 degrees Celsius. So the heat is coming, 400 degrees Celsius heat is coming. Now just let me see how the melting point is working. I don't want to take the other microcontroller bit, but I must about just shielding the microcontroller. Okay, so it is too late. Just see the how easy the socket come off. So if I go a little bit, I can see some more smoke is coming. I don't know which part the smoke is coming from. I will turn it off. I'll turn it off again. It is I don't have the smoke alarm, so I'm lucky. So I'll put it back there this way, and I'll try to see that. Okay, so this board is it's not very top quality board. I mean, it is not for rework, because as you can see with this low temperature, there is already some mark of melting. So I don't think so this is particularly for this job, but I will not give up the hope. I will give it another go. So if I take it back again and let me assess. Okay, so it is already, as you can see, it is already wobbly. So at the moment, let's not think about the big part. Let's think about much more smaller part. So basically, if I can just take a socket off, that will be it. So I'm just trying to draw the whole picture. How about that ribbon cable socket? Is it possible to take it off? Let's fire it up. So these are all hand-free settings. So I think this is a good settings I have come up with. This is the hand-free settings. I'm using my tripod arm to hold the soldering heat gun. So I will let you guys know the pros and cons and tips and tricks what I will come up with. Okay, so there is some soldering failure. So the circuit itself is just exploded and it has been taken off. It just fired off, pretty dangerous things, which I should be really careful with. I even don't know which component was here. It just shoot up. And I think this board is not for rework at all. So I will totally give up for this board. How about the other component? I don't see any sturdy looking board. How about this motor controller? Can I take it off? So just let me see with my brute force if we can take it off. Oh yeah, it's possible to take off. Okay, so it has got a micro switch. Yeah, basically I broke it, but that's okay. And again, I see this is not really a optimum quality board. I don't think so it will take the heat, but I don't know, should I give it a go? Okay. I'm still thinking maybe it's not a good idea to work with this board because I have tried my other board for reworking from this board when I was using this development board. This is a PIC control PIC 16 microcontroller development board. As you can see, the microchip symbol is there. I took off all the components without any burning or things like that, but certainly this board, not every board is for rework. Then what should I go? Okay, so on that case, we should have call it a day, but guess what? I have come up with something else. So I am practicing with the 555 timer circuit, and I made this little circuit. I'll make a detailed video regarding this once it is made more decent way. So basically, this circuit itself, if you power up 5 volt, so what this circuit does is this. It has got resistor and capacitor settings, so it can make at the moment it is like monostable state, so it can turn on the LED after some interval with this variable resistor. So if I can power it on, I don't have any DIY power source, so for this I use my robotic car battery as a power source. The robotic car has got a buck converter, so basically this buck converter I use to power it on. It is pretty primitive settings. So basically that's how it is. You need to invest money to do things, but you're never sure that how far you can go. There are no point spending money when you will not be able to give your proper effort. So as you can see, this is the buck converter, and it has got 5 volt in it, and too much resistor happening here, you already know. So I will just power it on. The setting is such that I will just power it on, and as you can see, the LED come on. So the LED came on, and after some time, as I am reducing the resistance, it will be blinking. It will be blinking much more. It's not that fast yet, but it is blinking much more faster rate. Then when I am reducing the resistance, it will blinking slower pace. How about adding a series capacitor, a series resistance with it? Shall I try with? Okay, let me try a series resistance. So I will add a 330 ohm resistance, see how it behaves. So now I will just do some tweak. I will come up with a digital circuit and a digital tutorial later on, but for now just try to get a series resistor, see if this change. Obviously it will change something, but what will change? Okay, so the series resistance is there, and the circuit is blinking much more slower pace. So I have reduced the resistance, and you can see the 555 timer circuit is turned off for longer period of time. I always wanted to go more detail about circuit. I've done some project during my bachelor and MSc, but obviously the condition is such that in my place of work we don't work so detailed. I mean, we don't work with embedded system. We're not in R&D, research and development section. So basically, some people they make the machine and we fix it. We are given training and we work with the machine. But always, I have aptitude to know more about going detail how things works, and get a skill, get a necessary skill for me to develop things on my own. So at this stage, as you can see, the timer is working, it is doing its job. So it is in monostable timer mode. This is basically just some discussion, and obviously you know that in this is my notebook, this channel is my notebook. Basically, I let you guys know what I am up to, and I would like to take you guys with my with me in my journey as well. And thank you for watching all this. I will see you at next time. Thank you very much.